If you can now please welcome to the stage, we have Federico Viggia Bombardi, Regional Business Development Manager at Continental Engineering Services. I will let you go through your session with technologies and engineering services for the development of automated people moves. Thank you.
Okay, good evening, and as I explained, my role is a Business Development Manager for Continental Engineering Services for the Italian market. So my aim for tonight is to give you an introduction of our company and also what we do in the field of automated people movers. So I will go fairly quickly. I guess you know probably Continental for tires, which is our most famous product, but Continental now makes around 60% of their turnover on automotive electronics. We at Continental Engineering Services work transversally across all the electronic areas of Continental. So we are basically a bit of a hybrid between a classic automotive tier one and an engineering company. So we are basically a technology provider. And we are also a one-stop shop from the idea to the product. We are also a gateway to high-volume products for those OEMs that are usually below the radar of a big company like Continental. And in general, we develop technology for mobility. That is our core business. Our main areas of operation are interior electronics, so basically human-machine interface, comfort and connectivity, ADAS, autonomous driving, vehicle dynamics, so chassis and brakes controls, driveline and electrification, so hybrid and purely electric powertrain, systems engineering, and then we have some more specialist areas like acoustic solutions, limited series manufacturing, which complements all the areas above, and a small group taking care of IT and cloud solutions. A few topics about the geography of Continental Engineering Services. Our group is headquartered in Germany, in Frankfurt. We have various offices across Europe, US, Mexico, China, India, Japan. Here in Italy, we have two offices, one in Torino and one in Modena, to cater to the two most important automotive areas of our country. Commercial offices with local project management and engineering support. And we have also a small location inside the Balocco test track where we can test the vehicles of our customers. Basically, in terms of products, I've already highlighted the areas where we work, and I will give you some more hints later. We also deliver engineering services in a packaged way, usually, and they go from concept development, so either writing requirements for our customers to search for products on the market, either in our portfolio but also outside. We develop electronic architectures for vehicles. We take care of aspects like functional safety and cybersecurity. Then going, let's say, down in the V-cycle, we do product development, software, hardware, electromagnetic, mechanical, wiring harness, MVH. We can take care of some specific aspects, so consulting, troubleshooting, homologation support. We can advise companies on how to best structure their R&D process. This is also something that we get asked more and more often. And we can support industrialization. So we can help our customers in all the various phases of the development cycles. Then going back up on the V-cycle, we can help with the integration, so system, software, vehicle integration, mechanical integration. We also have workshops that can be used to do that in a safe and secure way. They are TISAX certified. We help with testing and simulation, either as part of a product development or as a standalone service. For example, we can test complete electric drivelines, electric motors, inverters, brake systems. We can test complete vehicles, but also hardware in the loop on any kind of ECU. And as I said, we can do also road vehicle testing and truck testing, for example, in Balocco. In terms of manufacturing, basically, we do all types of automotive electronics, either of our own development or a build-to-print based on a customer development. We can take care of prototypes, also mechanical components, and we work usually with small and medium series. So small and medium series, I mean, from 100 parts to 1,000, 10,000, up to 200,000 parts per year. And finally, we can also manufacture wiring harnesses and high voltage cables. So a complete technology shop. I would say, except the body in white, the trims, we do pretty much everything else, and except the engine, the internal combustion engine. We work mainly in automotive, but we also try to expand the scope of our technology to other sectors, so commercial vehicles, motorbikes, but also people movers, which is the topic of today, off-highway, marine, aerospace, industry. So there are a lot of applications for automotive components that are mature in our industry, but maybe helpful to other industries that are coming to those. And we start usually by modifying components that are already in the Continental portfolio, but often we also design components from a blank sheet of paper. We have the capabilities to do that. And in general, we try to be a partner for both the development and the component supply, or one of the two, but we can complete the cycle, let's say. Here you can see some of our customers. There are mainly small OEMs that do sports cars, limited volumes, but we also see tier ones and big OEMs. For example, we work sometimes on the special projects of big OEMs. Going to the technologies for people movers, this is a topic that today is very, very hot, because these people movers are coming to our roads, initially to limited areas, like some of those we have worked on. In some cities there are dedicated areas for autonomous vehicle testing, like also here in Torino. And in general, these kind of vehicles are coming from an era when they were the domain of startups to a more industrialized approach. Hence why companies who develop them are coming to tier ones like Continental to source for products. And we inside the company are responsible for these, let's say, innovative topics like people movers. So a little bit different from the usual automotive business, and we'll see why. Basically, as I said, we deploy also for people movers technologies in interior, safety, so braking systems, airbags where there are, ADAS, and in general we support also as an engineering partner. So for the system, engineering, EE architecture, functional safety, cybersecurity, we take care of advising on the best layout for the braking system. We can design the complete electric powertrain, so not just the components but also the system. Cloud and fleet management solutions development, using our hardware as a support for connectivity, for example, and then integration of these components on board the vehicles themselves. Here you can see some examples of technologies that can be deployed on people movers. We know that especially in some markets in the Far East, for example, the wow effect is very, very important. So hence why I've included these. So these vehicles must have a futuristic flavor, let's say. So starting from the top left, you can see the Into Visible technology that I also invite you to experience at our booth, number 109, here at the VTM. So it's a back illuminated display, which has the peculiarity that when it's off, it's completely matte, so it doesn't seem a display, it seems a trim panel of the interior. Here you can see a wood effect, but other effects are possible, for example, aluminum, carbon fiber. And while this has been developed primarily for passenger cars, we know that, for example, in a luxury environment like some sort of people movers, these could also be deployed very effectively. Pillar-to-pillar displays, again, you see it on a car, but that doesn't mean that it's only suitable for cars. It can also be used on a people mover, for example, to project information that must be visible by all the passengers, so it's very wide. It can be divided in 3 areas that can be back illuminated separately. So also depending, for example, on the number of the occupants, all can be illuminated, only one. The message can be repeated, or it can be used as a single screen. Let's say an evolution of that same concept is the scenic view head-up display, which is on the bottom right, and that is basically a blend between the exterior environment that you see through the windscreen glass and the information that is projected on this black fascia at the bottom of the windscreen. For example, for a people mover, could be indications on what you see through the glass, monuments, or bus stops, or whatever other service might be relevant to the occupants. And this is really an advanced product because not only it is visually appealing, but also, let's say, highly connected to the world outside. So the computational capacity of that system must be really, really high, and that's why it's, let's say, a cutting-edge technology. Then finally, smart cockpit HPC, high-performance computer, that is, let's say, the force behind all those systems. So a very, very powerful computer that is especially suitable for the processing of images. And this is basically the heart of the modern interior HMIs. Without so much computing power, nothing of what you see on this slide is possible. And these are all products that we can deploy from Continental portfolio. They are already existing. We can deploy them and adapt them also to a specific mission that maybe is a little bit different from the one that they were designed for at the beginning. Then, let's say, to go a little bit more into the realms of the black boxes, a very important aspect is connectivity for such autonomous vehicles, because we know that in order for them to be fully autonomous, they need to receive an enormous amount of information about the road, and hence 5G and especially always-on connectivity is very important. For these, we have a range of telematic control units. The most advanced ones are the 5G telematic control units. You can also see one at our booth, and these are, let's say, fundamental for any kind of autonomous vehicles or vehicle with a high grade of autonomous drivability. In order for all these systems and the network to function properly, gateways are necessary in order to connect the various parts of the CAN network, and especially for a vehicle like a people mover, they must be very secure in terms of cybersecurity. Sometimes the requirements are a little bit different from those of the car, because maybe they require 24 volts instead of 12. So we have, again, a range of components that are scalable also to cater to this need. Finally, on the interior side, there are comfort functions. These vehicles have usually a very high focus on comfort, and so why you need, let's say, the basic ECU for any comfort function, which is the body control module, like in a car, for example, but also some special effects that can be achieved, for example, through control of interior lights, so light effects, shading, color changing, etc. And we have the ECUs to allow these functions. And also other comfort functions, for example, on the seats, also depending on the level of luxury of the vehicle. We have, let's say, multi-purpose ECUs for the seats that can control from the basic movements to adapt to, let's say, the body of the occupant, but also other functions like ventilation, heating, even massage. And we also have an example of these at our booth. So again, this is not primarily for people movers, but can be a really good point to, let's say, offer a good travel experience to the occupants, especially if the travel maybe is a little bit longer than just a city commute. Then finally, these vehicles, in addition to being comfortable, also need to be safe. Hence why the chassis control and the vehicle dynamics, the ride dynamics is very important, because we want to offer a very high ride quality to the occupants so that they don't suffer from movement sickness. Hence, for example, the control of the suspensions is very important to minimize the movements of the vehicle body. Hence, an air suspension can be a very good idea to deploy on such a vehicle to increase the comfort level, and we can supply the complete system, and in particular the air suspension control unit that can be used for ride quality improvement, can be used, for example, to lower the body when it comes near a stop, if it's used like a sort of autonomous bus, these sort of applications. Then, of course, the braking system must be very, very safe, because we are speaking about an autonomous vehicle, so it must be redundant, must be electronically controlled in order to be interfaced with ADAS, and hence we are among, let's say, the world's biggest suppliers of electronic brake units. This is one of our really core technologies. And finally, for when the vehicle is at a standstill, we have electronic parking brakes. And again, these systems need to be particularly redundant with respect to cars. Then, of course, since the vehicles are autonomous, they need to be informed about the world around them. So they need to see the world. So radars, cameras. We have a wide range of products that are completely off the shelf, and then we can develop software functions specific for the kind of mission that the vehicle needs to be deployed on. In order to process all the signals from the various eyes, let's say, of the vehicle, it's necessary to have a very powerful ECU that is now becoming a sort of domain controller. Let's call it automated driving control unit. And again, we have a range of products from the simplest ones to the most complex one that can deal with fully autonomous drive. Finally, in order for safety to be at the very best, airbags, and we also offer airbag control units, and through partners also the airbags themselves, and also internally we have our own crash test center in Alzenau, Germany. Before, I also mentioned the system aspect. So basically, the system aspect is what makes the vehicle work in whatever function is deployed. So sense, plan, act. We take care that all these various steps work together, they speak to each other, and there is no bug, there is no roadblock, so everything works smoothly. That is, in essence, what we call system engineering. So making sure that the requirements of the various components are very well harmonized together. There is no bottleneck. We take care that the communication between the various devices is secure, both inside the vehicle and with the outside world. And we take care that the architecture is rational, so that, let's say, the maximum can be achieved with the minimum effort in terms of components. Because sometimes what happens is that components are over-specified, then they are poorly integrated together. The end result is not satisfactory, even if the very best components have been employed. So, for example, we see a tendency sometimes to over-specify the component requirements in terms of functional safety. Sometimes we suggest our customers to look at system level, because maybe by delivering an optimized architecture, it's possible to use components with a lower functional safety grade, which are cheaper, but nevertheless equally effective if deployed correctly. An important aspect is comfort, as I already said. So brake brake system is really important. We don't want any unwanted noises, NVH. So we have specialist teams of people that can test braking systems, and in general, they can also specify the brakes, they can help with the routing, they can help with dimensioning, all those factors that make the difference between a good braking system that works and an excellent braking system. Don't forget that those vehicles, the autonomous vehicles, being autonomous, they are almost never at a standstill. They are used for a lot longer than normal passenger cars, so everything must be extremely reliable. Brakes, also powertrain, we do the same here, so we can specify the full powertrain system and we can supply some of its parts, especially power electronics. We can also specify and build wiring harnesses, high voltage cables, and finally we can help with the electric powertrain integration, which is a fairly complex area because all those components are bulky, they're heavy, they have high voltage in them, so they need to be, let's say, taken care of with some attention. And this is also something where we have specific experience on people movers. I will quote a couple of examples here of recent projects. One of them is Holon. These are all, let's say, public information that you can also find on LinkedIn. This is an electric automated people mover that is being developed by this German company, Holon, which is part of a big engineering group. The development is based on the best automotive practices, which is, let's say, the background of the mother company of Holon. It's also our background. And here we have really cooperated on a high number of areas for this vehicle, both for the initial conception of the vehicle, so engineering, and then also for the product supply in low volume, because these vehicles are just starting to appear, so we are not speaking about a very, very high number of parts. So we have specified the complete electronic architecture of the vehicle, which means crafting the requirements, deciding which functions goes on what ECU, specifying each ECU, also, for example, specifying if we want a zone architecture, a domain architecture, or a more distributed one, like is used currently in cars, or if you want something a little bit more forward-thinking. And then we have searched for all the electronic components in our portfolio and on the market. We have supplied the body control module, so it basically oversees all the body functions, all the body electronic functions, light, doors, etc., and the gateways, in order for the various parts of the system to speak with each other. We have also supplied important parts for safety, so the redundant braking system, and some accessory parts like wheel speed sensors. And not only we have supplied the parts, but we have also taken care of the application engineering. Another example, this is another electric people mover, designed and developed completely by Continental. There are a few examples of this vehicle operating in Germany, in Berlin, and also in other places, especially near hospitals. They work on very short trips, let's say. And here we have taken care mainly of the powertrain and the automation system. So we have completely specified the powertrain, which uses 4 electric motors and a 48-volt architecture. Again, for safety purposes, it doesn't need to go very fast, so it doesn't need to use high voltage. And the complete automation system, which uses radar, cameras, and LiDAR, so the complete technologies that are available today. As on the Holon example, we have also supplied the electronic brake control unit, which works together with the ADAS system to completely control the vehicle. We work also for our mother company as an engineering internal center of competence, let's say, and again, this makes no exception. We have selected the various components. We have specified the complete architecture, taking care of the packaging, mechanical and electrical assembly, so not only electronics, and we have built up the first prototypes. So these are two examples of vehicles that are on the road, where we have played, I would say, probably the biggest part among all the suppliers for electronics. I know that this is a topic that is booming. I hope to receive some questions, maybe some visits at our booth, and we will be happy to support. Don't forget that all these technologies that I've mentioned them in the framework of people movers, but they can also be used in passenger cars, commercial vehicles, other applications like, for example, some off-highway applications. We are getting some interest sometimes from aerospace companies. So in general, all the areas where comfort needs to be improved, safety needs to be improved. Okay, so if there are any questions, I'm happy to answer. Otherwise, I think...
Any questions, anybody? Notes, please.
No?
Thank you. Okay. Hello, sir. Sorry, I was late for your speech, but so I may missed some parts. So I'm curious about the concept you mentioned about the people mover. You mentioned that people mover and also other human vehicles. So you mean the concept of a human mover is not the cars or the vehicles can be run on the open roads we have in the current society?
So yes, there are various forms. So can be people movers in the form of a small shuttle bus, for example, but also pods for 1 or 2 people, and not all of them run on public roads. For example, what we've seen is a very high interest, especially here in Europe. Maybe in other parts of the world it's different. For people movers that move in restricted areas like parks, commercial centers, these sort of airports, these sort of applications. And it's a little bit easier because they are kind of ring-fenced, let's say.
Okay, thank you.
Okay, anybody else? No? Thank you so much for being here,
Okay.
Federico.
Thank you very much for hosting us, and please visit us at our booth.
Yes.
Thank you.